So the next lesson in Module 8 is Module 8.3, and now we are getting into negative exponents. So let's look at our learning target. I can simplify expressions containing 0 and negative exponents, and I can simplify expressions containing negative exponents. So our vocabulary for this is zero exponent property and negative exponent, and then of course we have order of magnitude. Okay, so let's talk about the zero exponent property. So that basically tells me that any number which is raised to the 0 power is going to equal 1. So for example, I say a to the 0 power. A to the 0 power is equal to 1. 86 to the 0 power is equal to 1. 25 to the 0 power is equal to 1. It doesn't matter if it's, a number. Once again, it is a non-zero number which is raised to the 0 power. It equals 1. So looking at this property, let's go ahead and solve some problems. Okay, so I'm going to bring you here. And let's look at these two problems that I have put on the whiteboard. And we are looking at simplifying each expression and assume that no denominator equals 0. So now let's look at this first one. I can immediately see that the entire expression has the power of 0. So looking at that, I don't even have to stress out by looking, I have to simplify. You don't have to do anything, because since the whole thing is the power of 0, this one, my answer is going to be 1, because I just said anything to the 0 power gives me 1. Now, let's look at the next one. I can see that this part, b raised to the 0 power, is going to be 1. So ultimately, I have a to the 4th power times b to the 0 power, which is 1, over a squared. Right? So the next thing that I am going to do is I am going to use the quotient of powers, and this basically means what? A to the 4th power, right? Because it's times 1 over a squared, and we have done this before, so that gives me a to the 4th power minus 2, and my answer is going to be a squared. All right, and that is my final answer. So let's go ahead and do another problem like this. So let's look at this question. And it's asking us to select the simplified form of this on the top. Okay, so first I need to look at, is there any base which is raised to the 0 power? Because that automatically means that all those numbers will become 1. And I can see all of them over here at the bottom. Okay, so this is going to be, all right. So this is going to be, we have 56 g squared h j raised to the 11th power over, I have 8 g raised to the 0 power is what? Times 1. H raised to the 0 power is what? Times 1. J raised to the 0 power is what? Times 1. Okay, and then I can see that the coefficients 56 and 8, we can look at that, and we know that 56 is divisible by 8. I get 1 and I get 7. So I'm simplifying. And so I'm now just left, this is 1 times 1 times 1 times 1, right? So I'm just left with j g squared h j raised to the 11th power, and this is my final answer, which would be A. Okay? Now, let's go ahead and so this was everything raised to the 0 power. Now let's go ahead and talk about negative exponents. So next thing we're going to learn about is the negative exponent property, and we need to know that any non-zero real number can be raised to a negative power, and that power is called a negative exponent, right? So now here is the negative exponent property. So if I say a raised to the power of negative n, that's nothing but the reciprocal. So I'm going to write it as 1 over a raised to the nth power. Okay? For example, if I say 3 raised to the power of negative 5, I am going to write this as 1 over 3 raised to the 5th power. So basically the reciprocal. And then I am looking at this as to what does that actually mean. So this means 1 over, I'm going to use the base which is 3 as a factor 5 times, right? And so I get my answer as 1 over 243. And that is my final answer. So basically, once again, negative exponent property. When I'm given something like this as a negative exponent, all I'm doing is taking the reciprocal of that. Okay? And that's how then I write it out and I solve it. So there are certain rules to remember with negative exponents to know whether the expression is considered simplified or not. So we need to know that when is an expression considered simplified? So first and foremost, it should only contain positive exponents. No negative exponents in there. It has to all be changed to positive exponents for it to be considered in simplest form. The base should not be appearing more than once. So each base should appear only once, exactly once. For example, I can't say b squared times b cubed. You've got to write it only one time, and I'm going to use the multiplication properties of exponents, and all I do is I take the b, the 2 plus 3, and that is b to the 5th power. So I'm going to say that base b only once. I cannot say it 2 times, and that goes for any of the bases. The bases need to be written only one time for it to be considered simplified. There should be no power of powers. So I cannot say 2x squared and the whole thing cubed. I've got to use the power of power property, and I got to solve that and put it in the simplest form. And then all fractions are in simplest form here. So these are the 4 important things to remember when an expression is considered simplified. Okay, so let's go ahead and solve some problems. So here is a problem, and we are going to simplify this. And of course, we are going to assume that the denominator does not equal 0. Okay, so let's go ahead, and the first thing we are going to do is we are going to write as a product of fractions. So I am going to say I have a cubed over 1, all right, times I have b raised to the power of negative 4 over 1, and then I have 1 over c raised to the power of negative 2. Okay, and then I am going to go ahead and use my the property, the negative exponent property, and I am going to do a cubed over 1. All right, and what is going to happen here? That is going to become the reciprocal. So 1 over b to the 4th power. And then in this case again, this is going to become the reciprocal. So c squared over 1. All right, and then once I have that, I'm just going to multiply. A cubed times 1 times c squared gives me a cubed c squared over 1 times b raised to the 4th power times 1 over b raised to the 4th power. So now look, we have each base, and that has been written only once. Right? All the exponents over here, they are in the positive form. We don't have anything negative. All right, we cannot have any negative exponent. We can only have positive exponents. And so this is my simplest form of this problem. So here's another problem, and we are going to group the powers once again with the same base. So here I have 3 and 36. Those are the coefficients. I'm going to group the coefficients together and then the same bases together. And so since it's 3 over negative 36, I'm going to say negative 3 over 36. And then I have g raised to negative 3 over g cubed. Then I have h squared over h. I'm grouping the same bases together. And then I have 1 over j raised to the negative 4 power. So once I have this, I'm going to start using the quotient of powers and negative exponent properties. So this in the simplest form, because remember fractions have to be in the simplest form, and we just talked about that. So this gives me negative 1/12. Okay, and then the next one, I'm going to do g, and this is negative 3 minus 3. Okay, and then I have h squared minus 1, and then over here I have the reciprocal of this, which is j to the 4th power. Now, once I have this much, I am getting negative 1/12, and I have g to the negative 6th power, and then I have 2 minus 1, which is 1, so I have h, and I have j raised to the 4th power. Now, remember we said we cannot have the simplest form with a negative exponent. So, I can go ahead and do the reciprocal of this. So, that is going to give me negative 1/12. Here, let me do it here. Okay, that gives me negative 1/12 times 1 over g raised to the 6th power h j raised to the 4th power. And so my final answer is going to equal the simplified form. I know that if I have the coefficient of 1 on the top, negative 1, I don't need to put that, right? I can just say negative, and it's 1 times h times j to the 4th power over, what do I have? I have 12g raised to the 6th power. Okay, and here is my final answer. Here is my final answer. Solved. Okay, so once again, just group them. I could have also done another thing over here. Do you see I've done like minus 3 over here? I could have just done the reciprocal, and I could have brought that minus 3 down here. So I could have done 1 over g 3 plus 3. So immediately I would have got this part, 1 over g raised to the 6th power. So that's another thing I wanted to show you that you can also do. Okay, so the last thing that I do want to talk to you about is the order of magnitude. So please look at what that is. An order of magnitude is used to compare measures and to estimate and perform rough calculations. And the order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, the power of 10 closest to 105 million is 10 to the 8th power. Okay, or 100 million. So the order of magnitude of 105 million is 10 to the 8th power. Okay, so I just want to show you that. Sometimes we just use that little bit of estimation to perform rough calculations. Let's do a problem regarding order of magnitude so that you can understand what I'm talking about. So let's look at this one. Speed. The maximum speed of a peregrine falcon is about 90 meters per second. The maximum speed of a garden snail is about 100th meter per second. How many orders of magnitude as fast as a peregrine falcon is a garden snail? So let's look at this. And we are trying to see, all right, the garden snail is how many orders of magnitude as fast as the falcon? What are the orders of magnitude of each animal? That's the first thing we need to see. Okay, and then what is the ratio of the two orders of magnitude? So what I need to do is, first I will compute the orders of magnitude for each animal. And then I will find the ratio of the orders of magnitude of the snail to the falcon. And I have learned how to find the order of magnitude. Okay, so if I'm looking at this, the maximum speed of a snail is 100th meter per second. So therefore, the order of magnitude of the snail, of the speed of the snail, what does this tell me? Is moving that decimal 2 places to the right. Okay, I am going to get 10 raised to the power of -2. Okay, so first I'm going to have to do this. So I'm going to take this, and when I change this, this gives me 10 raised to -2. Okay, and that is the speed of the snail. Now, let's look at the maximum speed of a falcon. It's close to 100 meters per second. Okay, so because we are saying 90, but we are going to estimate. So it is going to be about 100 meters per second for a falcon. Okay, and if I'm saying 100 meters per second, that means that this one is going to be what? 10 squared, right? Because 10 times 10 is going to give me 100. And then I'm finding the ratio of the order of magnitude of the snail to the order of magnitude of the falcon. So, ratio of the snail to that of the falcon, which is 10 squared. Use my properties, I'm going to do the reciprocal, or I can just do this. I can do 1, 10, and I'm going to bring this down, so this becomes this. All right, 1 over 10 to the 4th power. Here. There we go. All right, so this is, remember I taught you how to do decimal, so this is 1/10,000th. So we know that a snail is approximately 1/10,000th times as fast as a falcon, or a snail is -4 orders of magnitude as fast as a falcon. Okay, because what is this? This is nothing but 10 -4. If I wrote it that way, if I did it this way, right, I would get 10 raised to -4. So that is why it's saying it can also be -4 orders of magnitude as fast as a falcon. On anything raised to the 0 power is going to be 1. And then of course I taught you that when I have a negative exponent, you are going to take the reciprocal. You know the different forms to know that it's in the simplest form. There are 4 things that I had gone over with you. So you want to go back and review that to make sure that you know your exponents are all in the positive form. Fractions are in the simplest form. You have the base only written ones. Okay, so these are all the things that I had talked to you about. All right, so make sure that you follow all that in order to simplify. And of course, there should be no powers of powers, because that is another thing that you have got to solve. Otherwise, it is not simplified. Okay, and that concludes our module 8.3. Have a great day, everybody.